Hello friends and welcome back to my channel. Friends, if you have not seen episode number 1, I would request you to go through episode number 1. Episode number 1 is titled Let There Be Light. Why I am saying this is because this is episode number 2 and it would be better that the continuity is maintained as well as the flow is maintained for a better understanding. And therefore I am requesting you the same. In episode number 1, towards the end, I had talked about discussing some scientists in the next episode. However, I have decided to take up the works of those scientists a little later. But first, I will talk about something very fundamental in this episode. What I have also done is I have categorized my episodes into two categories. One category is episodes, the other is FAQs. This is episode number 2, from directions to dimensions. In our school days in science, we had come across a very generic principle or a rule or a law that energy cannot be created or destroyed, but it can be transformed from one form to another. Einstein was of the view that this is applicable to many other entities, and one such entity is dimensions. So, how dimensions transform, the principle behind it, let's try to understand with the help of an example. What I am doing right now is I am plotting a directional map. A simple directional map that I am plotting right now. So this is my north, this is my south, this is my east, and this is my west. Now you assume that the plane of the board is the surface of the earth, and the motion can take place on this board or on the surface of the earth. Now we have two kids with us. One kid is known as Ram and he is standing over here at the junction of these directions. So for ease of discussion, let's call this junction as O, or the origin. And there is another friend of Ram. His name is Sham. So Sham is also standing along with Ram. And Ram and Sham both have completed their homework. They have taken permission from their parents to go out and play. So Ram tells Sham that today we are going to play a simpler game, and a game which is easy to understand and a game which is interesting. So Ram tells Sham that what we will do today is that I am going to travel a distance d in a particular direction, and you also do the same, and then after traveling distance d we will stop and wave at each other. It's a simple game that we should play. So they decided to do that, and therefore Ram started moving in the north direction, as they had decided that they will move in different directions. So Ram started moving in the north direction, and he moves a distance d and stops. Moves a distance d and stops. Now it was Sham's turn to move, but since kids are they have the tendency of doing things differently, particularly when it comes to looking at somebody else, they want to do things a little differently. So he thought that what Ram has done, I am not going to do that. I am going to do things a little differently. So what he does is, so Sham also starts moving, but he does not move in one particular direction. He moves in the direction in the northeastern direction. He moves the direction B in the northeast. It's some northeasterly direction he starts moving, but he moves the distance d, as was discussed with Ram. He moves the distance d, and he stops. He also stops, and they wave at each other, and they are happy. What do we observe in terms of the motion and the displacement of these two kids? What you would observe is that in case of Ram, his entire motion got converted into displacement d only in the north direction. Whereas in case of Sham, his motion got converted in two directions. So his motion got converted into displacements in two directions. You see, when he was actually moving in the east direction and also in the north direction. And therefore, Sham moves a distance x in the east direction and a distance y in the north direction. His motion has got split up into displacement in two directions. So a chunk of his motion got converted into displacement in the east direction as x, and a small portion of his leftover motion got converted into a displacement y in the north direction. And so it is pretty obvious, since his motion has got split up, and so his displacement in the north direction y is less than d, or his motion or the displacement in the north direction is less than Ram. Ram has moved d, he has moved y, where y is less than t. But how can we say that? In the diagram it seems to be what I am saying. But what is the principle which is controlling where I am saying that y is less than d? What is that principle? The principle which says that if you move more in this diagram in the eastern direction, you will move less in the north direction. What is that principle? That is what we need to understand. Now, in our school days, we would have learned a very simple formula known as Pythagoras Theorem. So, what is Pythagoras Theorem? Y square plus x square is equal to d square in this case, or I can write it as y square plus x square is a constant. This is the principle. This is the principle. Since y square plus x square is a constant, so the more I move in the x direction, the lesser I move in the y direction. The more I move in the y direction, the lesser I move in the x direction. So in this diagram, if I have to put that, I have to put it like this. I put that as north square plus east square is equal to constant. So the more I move in eastern side, the less I move in north, or vice versa. So if Sham decides, no, Ram, what I will do is I will further move in a direction which is towards the eastern side, like this. He moves like this. So what he is essentially doing? He is moving more on the eastern side and less on the northern side. This is y dash and this is x dash. Based on this formula, move more in north, more in east, so less in north. This is how the motion directions transform. Friends, a very similar principle gets adopted when it comes to transformation of dimensions. Dimensions also behave in a very similar way. The more I move in space, the less I move in time. The more I move in eastern direction, the less I move in northern direction. So more I move in space, the less I move in time. Which implies that there is also a principle, there is also a formula which dictates this transformation. So, does it imply that the same rule holds? Because again, the more you move in space, the less you move in time. Seems a very similar formula is applicable. The principle behind space-time transformation is very similar to the directional transformation, but with a little difference. The difference is y square minus x square is equal to constant. This is the principle which we are talking about in case of space-time dimensional transformation. This is not applicable. This is only for directional transformation. But the principle is very similar in case of directions and in case of dimensions. Now, if this is applicable, then we need to know why this is applicable and this is not applicable. This is a very important question to answer, which I will take up in the upcoming episode. Friends, I have just introduced or taken you very close to what we call as space-time diagrams. Just like this directional map, north-east or directional diagram, we also have similar space-time diagrams. Space-time diagram was given by a very well-known mathematician, Hermann Minkowski. Hermann Minkowski was Einstein's teacher, and as we all know, that Einstein was a kind of student who would not take up authority, and he would resort to a lot of questioning, and he would not accept things on face value. This was an observation by all his teachers, including Minkowski. And Weber and Minkowski, Weber was also his teacher. Weber and Minkowski were of the view that Einstein is a genius, but then he works in a very different way. He takes interest in areas where he thinks is correct and he leaves the rest. So that was the kind of relationship Einstein had with his teachers. And to the extent that Minkowski called Einstein a lazy dog. So that is the kind of relationship he used to share with his teachers. And so when Minkowski came up with his concept of space-time diagrams in relativity, Einstein did not accept it on face value. What Einstein said was that we should be having thought experiments taking into consideration physical reality as to how things will happen in the real world, and have thought experiments on that, and not based on some mathematics or some diagrams made on paper. So that was his assumption. And so he discarded it completely. But later he realized that what Minkowski, the concept of the space-time diagram that Minkowski came up with, were of real value. And he realized the importance of this tool. It is a great tool if you understand it to understand special relativity, and that's why I will take you step by step in a very easy way to understand in the upcoming episodes. I hope I have been able to explain the concept of dimensional transformation with the help of directional transformation, and we'll go into a little more detail in the upcoming episode. Friends, if you have liked my content, please join my channel, subscribe my channel, and press like button, and I'll be coming up with many such or many more interesting episodes. So we look forward to the same. I hope you liked it. So see you in the next episode. Thanks and goodbye.